Okay, we know that P of n is the statement which is 3 raised to the power 2n plus 1 plus 2 raised to the power n plus 1, 2. Okay, the first thing we need to do is to consider at n equal to 1. Anywhere we see n here, we call it 1. We have here to be P of 1 equal to 3 raised to the power 2, 1 plus 1 plus 2 raised to the power 1 plus 2. Okay, so we'll be having here to be 3 raised to the power 3 plus 2 raised to the power 3, which will give me 3 raised to the power 3 is 3 times 3 times 3, which will give me 27. And other root, same thing here, will give me 8. So if I add it up, what will I be having? 35. So I will ask myself, is 35 divisible by 7? Yes, it will give me 5, element of what? Natural number. So we now conclude that P of 1 is true. So if P of 1 is true, we assume that P of k is true for some k greater than or equal to 1. So what it means is anywhere we see n in this statement, we put k, we have here to be 3 raised to the power 2k plus 1 plus 2 raised to the power k plus 2 is divisible by 7 and is equal to any integer n. So when we cross multiply to make this the subject, we have 3 raised to the power 2k plus 1 plus 2 raised to the power k plus 2 is equal to 7 multiplied by n will give me 7n. So at this juncture, we'll go to the next step by checking to check if P of k plus 1 is also true for some k element of natural number. Okay, so what we'll be having is anywhere we see n in this practice problem, we call it k plus 1. We have here to be 3 raised to the power. Instead of writing n here, what we write is k plus 1, then plus 1. Okay, plus we'll be having 2. Instead of writing n, what we'll be having is k plus 1, then plus 2. Okay, this is what we are going to be doing now. So let's multiply this out. When we multiply it out, we'll be having something that looks this form: 3 brackets 2k, 2 multiplied by k is 2, then 2 multiplied by 1 is 2, then plus 1 plus 2 raised to the power k plus 2 plus 1. Okay, so when we use the law of indices here, remember how the assumption looks like. We can rearrange this to look like that too. So by having here to be 3 raised to the power 2k, remember that 1 is coming before 2, plus 1 plus 2 plus 2 raised to the power k plus 2 plus 1. So we use the law of indices now to have here to be 3 raised to the power 2 multiplied by 3 raised to the power 2k plus 1 plus here will give me 2 raised to the power 1 bracket 2 raised to the power k plus 2. Perfect. So here is 9 bracket 3 raised to the power 2k plus 1 plus here is 2 of 2 raised to the power k plus 2. Okay, so inside 9 of this we can get 2 of this out. So what we'll be having is 7 of 3 raised to the power 2k plus 1 plus 2 of 3 raised to the power 2k plus 1. What I have represented is just this expression that is here, just to factorize. So what will be remaining here is plus 2 brackets 2 raised to the power k plus 2. So the common thing here is to factorize. We have 7 raised brackets 3 2k plus 1. 2 is common, we factor 2 out. What will be remaining is 3 raised to the power 2k plus 1 plus this value 2 raised to the power k plus 2. Okay, the whole thing here, the assumption gives us notice that the whole thing here represents 7n. So we replace it. We have 7 bracket 3 raised to the power 2k plus 1 plus 2 into the bracket of 7n. So when we open the bracket, we have 7 bracket 3 raised to the power 2k plus 1 plus 2 times 7 in m is 14m. So what we are checking is if it is divisible by 7. So what we are factoring out here is 7. We have 7 into the bracket of 3 2k plus 1 plus 7 divided by 8 will give me 2m. So we say let 3 raised to the power 2k plus 1 plus 2m be equal to any integer m. So we now replace it here to have this implies that 7 raised to the power n, where n is element of any integer represented. So this is true about this statement. There is no possible value of n that you impute here that you multiply by 7 that will not be divisible by 7. So this implies that p of k plus 1 is also true. It's also true. Therefore, p of n is true for all n elements of natural number, and that completes the proof.
I beg, now we don't watch and say like just like comment. I did just beg you, comment now. Why you do that? You start. You want to go?